So during the last lecture sessions, we have come across several the terms and terminologies related to the theory of constraint. Particularly, say three important terms you must always remember. That is, the first one is the throughput. We have defined what is the throughput. The second one is the inventory, and the third one is the operating expenses. And we have the three important say the organizational performance measures. So the first one is the net profit, and the second one is the return on investment, and then the third one is essentially the amount of the cash flow. And what you try to do, that means the organizational performance measures must be defined in terms of these three terms. One is the throughput, the second one is the inventory, and the third one is your operating expense. So this is your starting point. Next, what we are going to discuss, that is the bottleneck and non-bottleneck resources. Okay, so we'll proceed slow so that your understanding will be appropriate, and later on when you take up many kinds of the modeling techniques, so if you have the basic understandings of the terms and terminologies and in which context they are relevant, then the understandings of the methodology will be real, also the appropriate. Now we have also defined what is a constraint, and the constraints can be of two types. One is the external constraints. We have given several examples. You try to find out the possible examples of external constraints. That is your starting point. And the second one is your internal constraints. So there are many examples of internal constraints. So some of these examples already we have given. And what we have mentioned, that the internal constraint is nothing but the bottleneck. Okay, so now we are reaching at a level where we need to define what is a bottleneck and what is a non-bottleneck with respect to a particular resource. Now, as has been stated in the last lecture sessions, I have already pointed out that the internal constraints are nothing but the bottlenecks. Okay, so that is point number one. Now, for the TOC, or theory of constraints concept, to be used in a manufacturing plant, usually just a point to be noted, though we are saying that the TOC is a general methodology which can be applied for any type of organization, but what you will find that the most of the case studies related to TOC, they are essentially the case studies related to the manufacturing systems, and more specifically related to say the job shop kind of manufacturing systems, or the repetitive manufacturing or discrete part manufacturing systems, or sometimes they are referred to as the batch production system. And as I have already pointed out, that the batch production actually consists of the 70 to 80% of the total production system in the industrialized the countries. And so the tools and techniques are mostly directed towards, such tools and techniques are mostly directed or say used or the developed for the discrete part manufacturing system, because this system is the most the complex one. Okay, there are the numerous factors affecting its performance, and getting a perfect or acceptable, okay, even a satisfying solution for the scheduling problems, it's a real challenge. So similarly, the TOC is mostly applied for the discrete part, the manufacturing systems and the job shop. Now, For TOC concept to be used in a manufacturing plant, the first consideration is identification of the bottleneck and non-bottleneck resources. So the first you must know that what is a resource. Once the resource is defined, then you need to define what is a bottleneck resource and what is a non-bottleneck resource. So what is a resource? A resource may be a work center, a process, a machinery, a facility, a department and similar such entities. That means, in other words, a resource is an entity where certain value addition is done. That means there is some value addition. That means suppose the raw materials is getting processed in a particular, so the machine tool and a particular machinery. So the input as a raw materials or the rough stock, output as a part or the process part. So this there is a value addition in terms of its use, in terms of its in the shape and size. So the value addition is there, has to be there. So this is referred to as a resource. So there are examples, like sometimes they refer to as the profit center, sometimes they refer to as the cost centers. Okay. So the definition of resource is known to you. Next is, there may be two types of resources in this context. There may be, the resource can be classified from several perspectives, from several criteria. So here our basic criterion is the constant. So in the context of identification and controlling the effect of constraints, so there are two types of resources we should be aware of. First one is the bottleneck resource. What is a bottleneck resource? That means in a bottleneck resource, the capacity is less than the demand placed on the resource. For example, suppose a capacity of a particular, say the machinery is say 1000 units it can produce of a given part per hour, okay, or per shift. So that is its capacity in terms of say production rate, or the number of the units, okay, in a particular say the time period. So that is the capacity. Now the demand could be, so suppose it's 1000 units per hour is, or per shift is its capacity, whereas the demand could be 1500 units on that same resource, on the same machinery. So obviously the capacity is less than the demand placed on the resource. So you treat this resource as a bottleneck resource. Okay, a very simple definition. So obviously if there is a bottleneck resource, there could be non-bottleneck resource also. So what is a non-bottleneck resource? That means the capacity is more than the demand placed on it. That means your capacity is 1000, but your demand is say 500 or say 200. There are many such resources you may come across at a particular point in time in a manufacturing plant. So the first thing you need to do, that means out of n number of such resources you have defined. Now how many are in the bottleneck category, how many are in a non-bottleneck category? So obviously the demand level must be known. If the demand level is not known, then obviously you cannot define what is the bottleneck and what is the non-bottleneck. Now the bottleneck resource should process those materials providing throughput. Now our main goal is something you produce which you can sell, and only when you sell you can get the throughput. So suppose you produce 1000 units at a particular point in time during a period of time, and you can just sell say 500 out of it. So obviously your throughput is 500, whereas the remaining 500 units it's basically is the waste. Okay, so waste should be as minimum as possible, and logically it should be zero. So why don't you produce as per why don't you produce in such a way that is it is converted into throughput. So that is the main goal of TOC. Is it okay? Please make a note of this comment. So what do you try to do? That means the bottleneck resources, because of its capacity constraint, you are unable to produce. That means there is a demand, and if you produce more, okay, than your capacity as per the demand, obviously you will be producing the throughput. So you have to think of ways and means of so the improving the utilizations or improving the performance of the bottleneck resource. That is point number 1. That is the first priority in any TOC exercise. Now with increased utilization of this resource, now utilizations, you know that what is the definition of utilization, but here in the under TOC concept, the utilization means that that means the number of units which you produce out of say the total number required. Is it okay? Or the total number say the given to be produced. Now if you utilize it, that means suppose the 50% of the time you are utilizing your the machine tool. It means that whatever you produce, say whatever this 50% you have produced, this 50% of the time you are running the machine, whatever you have produced, that you can sell. That means it is converted into the throughput. So with increased utilization of this resource, it is essential that appropriate product mix for the resource is selected so that throughput is maximized. That means many a time what happens, that because of inappropriate product mix, you are not getting the demand. So if you do not get adequate say the demand, obviously even if you produce, you cannot sell. And if you can say the change the product mix in such a way that the demand grows, obviously you feel like producing as per the demand requirement. Is it okay? As per the demand, so that the condition of say throughput production is met. Okay, so this is one. Second one, when we talk about the non-bottleneck resource, that means where the capacity is more than the demand, so it has obviously the excess capacity. This way we define whether a particular resource has excess capacity or not. If its capacity is fully utilized, then what will happen? It does not increase throughput, because you will be producing definitely. Its requirement is 500, its capacity is 1000. Now if you produce 1000, obviously the 500 units you cannot sell. So out of these 500 you cannot have throughput. Rather, inventory level increases, hampering performance of the plant. That means the flow of materials in different forms, the flow will not be smooth and the flow will be hampered. That means the flow rate. So it reflects essentially a bad inventory control systems and the bad production control. So this is to be avoided. The excess capacity of non-bottleneck resources. Now the question is that you have the excess capacity and the capacity is to be used. Capacity of excess capacity of the non-bottleneck resources. So what are the ways? That means you don't want that that the machine remains idle. That also you don't want. So what is the alternatives? The alternatives are that the excess capacity of non-bottleneck resource can be used in a number of ways. So these are the alternatives. The first alternative is the preventive maintenance. Okay, so why don't we use it for the preventive maintenance for that particular the machine tool. The preventive maintenance is a must. Is there any special problems with this machine? Normally this is the case. Each machine is a unique one, and while you start using a particular machine, suppose I am a worker or I am a supervisor or I am a manager, okay, the line manager. against a particular machine, I know that what are the special problems. So when you get say extra time, okay, so during this time what you try to do, you try to look into the special problems with respect to, maybe with respect to the design of that particular, say, the work center, or say its work holding devices. There could be some problems, automated storage and retrieval systems. Okay, so there are the different kinds of problems always you may come across with respect to a particular work center. So why don't you utilize the excess time for that purpose? And the last option could be the improving quality or quality of setup. So this is an important issue, when you refer to the throughput time of a particular manufacturing plant, so the total throughput time. So one of the important the element in the total throughput time in the setup, and as we have mentioned that the setup is essentially a non-value adding activity. So why don't you try to reduce it? So always you try to improve the quality of setup, and if you can improve the quality of setup, what happens that the setup time gets reduced, and the setup cost also gets decreased. So there must be a proper plan of work considering possible future requirements of the resource, and this is an important point. That means possible future requirements of the resources. So you must have say a particular work plan, or today maybe it is less loaded, but in course of time, so you must have the information of say the future requirements, and accordingly you have to make a plan. Like, so if you find that for a given non-bottleneck resource in future it is expected that this may become a bottleneck resource, so what you try to do, right at this point in time, you look after its preventive maintenance, the approaches, all these methods, whether improvement is possible, the special problems you look into, and you try to improve the quality of setup. Okay, so this is the context. Now there are three ways the available time at a resource can be spent. Okay, it is in general any resource at any machine tool or the work center. The three different ways it can be used. The first one is it is used for the production purpose. So that is quite natural. So this is referred to as the production time. So it has its production time. Processing time of the throughput time. Processing time of the throughput time. The throughput time consists of four time elements. The first one is the setup, next one is the processing, third one is the transfer, and the fourth one is the waiting time or the queuing time. So the processing time, essentially the production time you refer to, it's nothing but the processing time. The second one is the setup time. I have already elaborated, one of the important components in throughput time. And the third one is obviously the idle time. Okay, due to many reasons, there could be idleness or the idle time, waiting time at the resource. Is it okay? There could be many reasons, like the machine is okay, but it is waiting for the material. That's why the machine is idle. Or the material is there, the person is there, but the machine is not in working condition. Machine is under breakdown. Okay. Or the machine is in running condition. The materials are there. The person is there, but you cannot run the machine because the cutting tool there is no cutting tool, appropriate cutting tool available. So there could be many reasons that why a particular resource remains idle. So you must have a thorough idea. That means resource wise you must have this information. You cannot generalize it, as I have been telling you, that when you try to implement the TOC, that means it is to be implemented at the shop floor, at the plant level. That means it is a practical problem or a particular situations you come across. That means it's essentially a database modeling. So against each resource, the possible reasons of its idleness must be recorded and must be known in specific terms. For the bottleneck resource, how to the improves its utilization. Already it is constrained. So what are the ways and means with which you can improve its throughput production? So the minimization of setup and idle time is the goal. Here you focus. In many a time when you refer to the case studies, you will find that the practitioners they find there is a lot of opportunities for setup reduction, setup time reduction, and if the setup time is substantially reduced, so the time which you get that extra time which is can be utilized as the production time. Appropriate quality control techniques are to be used to ensure that the defective parts coming from the previous state are processed, are prevented. That means you don't allow the defective parts to come to a a bottleneck resource, because unnecessarily this defective part you cannot use, and the production time will get lost. So you will be losing on throughput. So there must be a check of for the quality of the incoming materials as well as the processed parts or the semi-processed parts to this particular, say, the bottleneck resource, for each bottleneck resource. So you must have a mechanism to control say the quality of the incoming materials, incoming parts to a bottleneck resource. Demand beyond capacity may be transferred to other non-bottleneck resources. So these options, these alternative also you can think of, you can try. Capable of producing the parts or the components products as per their specifications. Obviously, that particular say the non-bottleneck resource, whether it has got the right kind of capability or not, process capability, that you have to check, that you have to verify. Then only it is considered as an alternative. Now, controlling idle time at a resource is an important issue. For non-bottleneck resources, it is not a problem. For bottleneck resources, the setup procedure, a non-value adding activity, this point I have already mentioned, needs to be continuously improved so that extra time available by setup time reduction can be utilized for processing, meeting the demand imposed on the demand as quickly as possible. Is it okay? So what is important is that as we have pointed out that sometimes the JIT based approach also you can use. Like one of the important goals of JIT is that is the batch size of 1, and you can achieve this condition only when the setup becomes 0. That means the minimum 1, negligible. So obviously, if you have already implemented the JIT based approaches, so and if you focus on this particular aspect, so the technique is known, the systems of controlling the setup or minimizing the setup time, that is also known, and only thing is, if you can develop a generic approach, why don't you apply this generic approach in respect of particular resource? Like say, if you can implement single minute exchange of dies technique, SMED techniques as a generic approach, so why don't you implement it for say the bottleneck resource? So such approaches you should be aware of, and specifically which can say control the setup time, because the more time is required for production, and if you produce more, you will produce more throughput. Now we say an hour lost at a bottleneck resource is an hour lost for the plant, because essentially the bottleneck is essentially the controlling the system's output, okay, not the non-bottleneck. So if you increase the productivity of a bottleneck resource, this point you just make a note, productivity of the plant increases Hence, bottleneck resource must be continuously used, and production technology with new state of the art appropriate technology needs to be upgraded for the bottleneck resource. Is it okay? So, usually, what is important is, that means the initiative like technology upgradation has to start from, say, the bottleneck resource. Okay, so this is an advantage if you apply the TOC technique. Now, in this context, the certain the terms which are highly relevant in the TOC methodology, you must be able to define. Now, when you start using a particular resource, now you come across two specific conditions. One condition is activation of resource. So, what is activation? An act of processing at a resource. It's very clear. Not necessarily resulting in throughput. You just produce it, but you are not sure that whether this produced quantity can be sold or not. Okay. So, this is called activation. So, the necessary condition is activation, but the most important thing is, can you have a condition called utilization of resource? So, what is utilization of resource? An act of processing at a resource resulting in throughput, that is a sufficient condition. So, this is the necessary condition and this is the sufficient conditions. So, for implementing TOC, what you need to do, you need to meet say the sufficient condition. TOC requires that the resources are utilized, not only activated. Thus, producing to capacity for all types of resources may lead to high level of inventory. As throughput of the plant system is determined by utilizations of the bottleneck resource, utilizations of non-bottleneck resources is controlled by bottleneck resource. Okay. That means, as per the requirement of the bottleneck resources, why don't you use the non-bottleneck resource? So, this the linking has to be there, and hence we say that the bottleneck resources are the masters. It is essentially these resources guiding actually, or the controlling the activity or the production of the non-bottleneck resource. So, the bottleneck resources are the masters and the non-bottleneck resources are the servants. Thus, the main purpose of TOC is to balance the flow of work through the plant, not to balance the capacities or resources. Okay, so, whenever you talk about the balancing of the flow, that means we are referring to a dynamic system. Whereas, when you try to talk about the balancing the capacity, you are not necessarily referring to a dynamic systems. Essentially, you are referring to a static system. We attempt to model the actual dynamics of the system's plant operation with TOC approaches. So, in a manufacturing or production system, there is incremental changes in capacity over time, but the demand and product mix may change continuously. It is necessary that for improving, optimizing total system performance of a plant, we need to consider the bottleneck resources simultaneously for flow and inventory control. This point we have been elaborating all the time. It is also necessary to model the interaction between bottleneck and non-bottleneck resources. So, there may be different types of interactions. So, this is your starting point: identification of the bottleneck resource, identification of the non-bottleneck resource, and then what could be the possible relationships between these two. So, supposing capital A is bottleneck resource and capital B non-bottleneck resource. So, A is affecting B, B is activated as per the requirements of A. Now, B is related to A, that means B is activated as per the requirements of A. A is the masters, A is the controller. This is the non-bottleneck resources is related to another non-bottleneck resource. Both be activated as per the demand of another resource considered vital for the throughput production. So, this point is to be noted. A1 is activating A2, that means the linking A1 with A2, the least constant resource between A1 and A2 is activated as per requirements of the most constant resource. Is it okay? And A and B, both A is a constant resource or the bottleneck resource and B is a non-bottleneck resource. Both are actually linked with the assembly or the end product. Production rate at end product or assembly stage is controlled by that of A, not B. So, everywhere what we find, but basically the bottleneck resource must control the production rate or the schedules of say the other kinds of resources in the system. So, here you conclude, and in the next sessions we will go for say discussing other aspects of the theory of constants. Thank you.